hands wide so you can hear my voice. Excellent. Clap your hands if you're calm. Okay. Excellent. Calm got it. How we doing? Yeah? Energy? No energy? Some energy?
It's Friday.
Some? All right. Well, so I'm recovering. So you got to have at least as much energy as me, okay? Okay. Yes, I didn't die yet. Okay. So today we're starting a new something. Okay, so this is going to be totally different, which is fine. What we're doing is we're going to learn something called SQL, often pronounced SQL or SQL. Anyone know what it already stands for? Yeah, repeat. Structured query language. Nice. Okay. So there's going to be a lot of vocabulary today. So it might be a good idea to keep like some kind of running vocabulary list today because we are entering a new language with different terms, okay? So, structured query language. All right, so this is the language that we're going to use to access and get information from our databases. So does anybody know why we might want a database? What good is a database? Yeah, Doug? To organize all the data. Okay. So Doug says to organize all the data. Sure, right? But we've been doing that with like variables and whatnot, right? So what makes a database better? What's the motivation? Isaiah? It will keep code cleaner. Okay, maybe. Danny?
Storage.
Storage. What do you mean by that?
Just storage. Just if you have a database, you store stuff.
So he says we can store a lot of stuff in the database. Okay, I absolutely agree. But we've been storing stuff as variables. So, you know, what's wrong with that? Farah?
Just like in a table, you can say, like, I want everybody that's the doctor, or like, I want all the cars that are red, and it's like a lot easier and like kind of sort and query. I don't know if that's the right word to use, but with Excel, you know, they have the information, you can just get it quickly through the columns.
Awesome. Yes, so Farah says we'll have a lot of different ways to access information. So she said maybe better ways to access information. Okay, yeah, I agree. There's better ways to connect things. She said the word tables in there. She also compared it to Excel. I don't know. Can you raise your hand if you're familiar with Excel? Okay, so most. Okay, so that's some good things. What else? What else might we want a database? Why might we prefer a database? So I want to take us back to that time when we created an array of people and we added a new person to that array. Do we remember that? That was our first kind of connection with our front end and our back end. What happened every time the server restarted? What, Phil? It reset. What reset? The whole array, right? It reset to an empty array, an empty array of people. So the databases are really going to help us make it so information can persist. Okay? This is a key word, persist, right, when talking about databases. Persist means to continue being there. So essentially, even though I refresh the page and I restart the server, we're still going to be able to pick up where we left off and access all of the data that's already been added. Okay, so we never have to restart. Eric, can you imagine if every time you went on Facebook, you had to recreate your user and re-add all your friends. I don't think they would have made it. Right? But you have to, so they have a database. Okay. Questions on that? All right, so the next thing we should talk about here is a table. So a table is traditionally rows and columns, and this is very much like an Excel spreadsheet, if you're already familiar with those. Otherwise, I don't want to unplug this because of the recording. But, okay. So let's say we had a users table. So we're just going to call this users. The tables should be lowercase. The naming should be lowercase. Snake case. And plural. Okay, this is the naming convention. So user should be users, because this table represents multiple entries, multiple users. Okay? Tables should have a ID. So we're going to call that ID. The ID is something called the primary key. I know there's a lot of vocab. Primary key. This is what we're going to use to like look up entries, right? This is what differentiates each entry, is their primary key. The primary key should be unique. What else might a user's table have? What other piece of information? Yeah,
Attributes.
yeah, different attributes. So maybe we have a name. So we'll say name. And maybe we'll have an age. Okay. I'm not going to put too many attributes in there to understand. So this is your table. Right? This is your user's table. We have our columns. ID, name, age, etc. And then the rows are going to represent the different entries into this table. The ID doesn't have to necessarily be the sequential order. If you remember looking at the Ghibli API and we looked at the ID of the movies, it was like this random string with numbers and letters. Some databases will give you that. The ones we will be designing will mostly just have IDs of like 1, 2, 3. But you should not depend and count on the ID being in a sequential order. Okay? Let me write that. Do not assume ID order. Okay? This will be more important later. All right, so we have an ID. We say 1, we have our name. We'll put in there Corey. Age, we put in 100. Let's put in Jenya. 2, we say Jenya. Age, I forgot what you said your age was. 21. Right? John, what was your age? 26. Okay. Okay, cool. I'm like really old. Okay. So right now we have 3 different entries in our table, and that's our user table. Okay, this is what we should be aware of. We've got our primary key. We've got a couple attributes. Okay. I want you to now sketch out your own table with your partner over the next 5 minutes about a pet. Okay? Pet. I want you to make a pet's table.
Animal.
Oh, you could call it animal, sure. We could say, but I'm going to say pets. I want you to think of the different attributes your pet has and to come up with the table. Okay? We'll go to 7:15. Pets.
ID.
All right, clap your hands once if you can hear my voice. Clap your hands twice if you can hear my voice. All right, how do we feel about our pets database? Yes, no, maybe so. Who wants to share their pets database? All right, Will.
All right, so we have pets.
Right.
Yeah. First column is the ID, obviously.
Okay, and those represent what?
The key.
Yeah, so those are going to be the primary key, right?
Exactly.
Perfect, ID.
And then name, obviously. All pets have names.
Hopefully, yeah.
Type. What we're talking about that pet.
All right, so species or type. I gotcha. Sounds good.
Size.
Okay.
Age.
Age, okay, yeah.
And number of legs.
Okay, a number of legs.
Yeah.
I like it. Let's just do name type and size for now. Just so we have a smaller thing for the next as we build. I like that. So let's give our pets some IDs, names. Let's fill this out. So we have an ID for one. What's a good pet name?
Butch.
Okay, just throw up your hand. I can't hear it. Like, it sounds like Briop. That's going to be the first pet. What size is Briop? Big. All right, somebody said big.
Wait, that's the type.
Perfect. Big. What is Briop? Somebody said snake. Okay, here we go. All right, now hands. Who wants to give me the next pet? Will, sure.
Butch.
Butch. Okay. Butch.
Dog.
It's a dog. Okay.
Medium.
Medium. Okay. Great. And let's just do one more. Brutus.
Brutus.
Brutus, you want to be a pet? Yeah. All right.
And it's small.
Brutus is a small cat.
It's not small like that.
Okay. Go on.
Be lying so bad.
All right. So are we missing any important aspects when we think of pets? Farrah?
We also had like equipment needs, like cage, tank, leashes.
Okay. Yeah, those are definitely important things. What else? Phil? Color. Yeah. I don't know if that is super important, but it's definitely something we could add. I agree with you. Yeah, Doug? Owners. Right. Do pets have owners? Yeah, pets have owners. So what's that look like? Right? So this brings us to our next. So there's a few different types of relationships I want us to think about when we think of databases. Specifically, the databases we're talking about are RDBMS. I'm going to write it. RDBMS. And this stands for Relational Database Management System. Okay, and so essentially what we want is our data tables to be able to reference each other. And when tables can reference each other in our data, instead of creating duplicates, this is called normalization. That's another normalization. Say tables reference refer to other tables. Right? Because we could just duplicate a bunch of information, but in some tables, there are that. There's different types of databases. You should be aware of that as well. There's some that use SQL. There's some that are no SQL. And it's all about how information is stored and how information is accessed. Okay, so we're mostly going to be working with Postgres in this class. That's that little elephant that you installed at the beginning. That's at the very top of your toolbar. Postgres adheres to SQL rules, but there are other SQL databases that don't strictly use SQL. That they might use something called MySQL or different forms of SQL. A lot of them have a lot of similarities, but you can rarely take just one query from one table, one database, and then pass it into a different database, unless they're using the same thing. They'll have to make some adjustments. Just something to be aware of. So Postgres follows most of the rules of regular SQL, which is the new language we're learning today. But we actually haven't learned any SQL yet. Just kind of learning about the tables that SQL will access. Okay. So back to the relationships idea. So I guess I'll start writing on this board too. Yeah, this isn't like a great computer lesson. So we have a 1-to-1 relationship. So a 1-to-1 relationship, one example of this would be, I have one social security number, right? And that social security number just has one of each. Right? So we each just have one of each other. The social security number doesn't belong to anybody else. It's only one person, and that one person has the social security. Okay? Yeah, okay. The second relationship, type of relationship, is a one to many relationship. Okay, an example of this in real life might be like a museum. And works of art. Right, so a museum has many works of art, but a work of art belongs to one museum. Okay. The third relationship that we're interested in is called a many to many. Right, so an example of these might be a student in a class. So the way to read these is this belongs to and this has many. Okay? Those are like the kind of the words you think you should be thinking in your head. Belongs to. So a student has many classes, and a class has many students. Right? You don't just belong to a class and that's your own class. I mean, you do it in pursuit, but not in a regular school, right? While the class has a lot more than one student, otherwise it's just too very one person. Right, so just like a work of art belongs to a museum has many works of art, and one-to-one, we can say like a person, an SSS or something. So like the Social Security number belongs to a person, and a person belongs to a Social Security number. Okay? So over the next 5 minutes, split into groups of like 3 or 4. Try to come up with like a few real life examples of each of these. Okay, and then we'll start to think about it.
Can you explain that third one more time?
The third one?
Yeah, the many to many.
So a class, does it have many students or one student?
Many students.
Class of many students. Does a student have one class or many? Many.
Oh, okay, so in both cases.
They both have many of each other. Excellent question. All right, so we're going to go till 7:30. Come up with some examples of each of these for real life.
This one.
But technically, yes,
All right, let's hear some popcorn around here.
one fingerprint.
Fingerprints?
Yeah.
Oh, yeah, sure, okay. Person to fingerprint. Cool. Yeah, Rafiq. Can you speak up? Bank account number for a one-to-one? Sure. Say. All right. What else?
Have a one-to-one computer keyboard.
Okay. Computer to keyboard, that's cool.
Address of the building.
All right. Address of the building.
Concrete flag.
Flag. army has lots of soldiers, while a soldier can only belong to one army. Hopefully. Double agent. Who's got the last name?
A mother to her children.
A mother to children?
Yeah. That's one to many.
Okay. Could that be a one-to-one too?
Yeah.
One. Yeah. And Brutus? Birthday? Tell me more about one birthday, but like a lot of it's more than one. Okay. One's many that are shared birthdays. Okay. How about many and many? Yeah. Shia?
I thought person to bank because
Versus the what?
person to bank because a bank can have like many clients and then clients could have also be accounted for in many banks.
Okay. Yeah. So we would have like people and banks. Because you can belong to multiple banks, and the bank has multiple people. That's great.
Public company.
What?
Public.
Public company? Okay. Tell me more about that.
Like investor or company.
Who?
Investor.
Investor? Okay, yeah, investor company. I like that. All right. Daniel, did I see you had one too?
No.
All right, I think that's it's probably sufficient amount of examples. Right, so I want you to start trying to think about relationships that way. So, to go back to our pets example, what kind of relationship is this? Brandon? One to many? Why?
There's one ID, for that one ID, there's many elements inside. What that belongs to, it's that ID.
Can you tell me a little bit more what you mean by that?
Like, there's, each ID is unique, and that one ID has many, like,
Which ID?
like, anyone has elements inside of it.
So these are multiple entries. This all includes one specific object. You can also start thinking about this a little bit in the world of like, remember OOP, object-oriented programming? And we were like breaking things up into what they're responsible for. I want us to keep thinking about that when it comes to these, like having a user stable and a pets table, and how they might interact, as well as what pieces of information. These are like objects, essentially, that have been created and saved. You see how you have something?
Yeah, basically like it is one time which is one many operations.
I'm not hearing you, sorry.
One table, like for example, users, but there is like many operations.
There's a lot of information inside
Yeah.
of user table. Yeah, there's a lot of information inside of user table, but how do we want that to relate to our pets table? Isaiah.
I thought it was one to many because a pet can have one owner or multiple pets.
Okay, so Isaiah says it's a one-to-many because an owner can have many pets, and a pet can only have one owner. Okay. Is that true? Rafid?
I think it would be many to many because, well, first, like with that example, a person can have many pets, and a pet can have more than one owner. So if it's a couple of owners, the pet could be four owners.
Okay, so Rafid says a pet has many owners, and an owner can have many pets. So he says it's a many to many. How split are we? One to many? Many to many? Okay. So a lot of people aren't voting. Don't know? Now's your chance. Okay. So I think this is a many-to-many relationship, right? I think that makes the most sense because, like, my cats are also my wife's cats, and I am saying cats because we have plural. So there's many people on both sides involved there, and many cats. Let's pretend for now, though, that it was just a one-to-many. So let's pretend that a pet belonged to only one owner. Okay? Just for fun right now. And an owner still can have many pets, or a user, whatever we call it. How would this database change? How would our pets database look at our users database, or a table, sorry. How would our pets table look at our users table to keep track of that information? Take 1 minute with the person next to you. Brainstorm. Yeah. How can I keep pets and users looking at each other? How can I connect them? If it was just a one-to-many, what would I do to connect them? Think about it for a minute. Let's get them out of there. Right? What? All right, what do we think? Karen?
You add the ID to the users table,
Add the ID to the users table?
and you can move forward with the pets.
On the pet side table.
Yeah. So we do it once a minute.
Which table should I add an ID to?
So the users table,
Okay, what's it look like?
so let's say, you could say ID or pet ID.
Okay, so we say pet's ID, let's say.
And for the ID that exists in the pets table, you can use it there.
Okay, so if Brewer belonged to Corey, we would say 1. If Butch belonged to Corey,
Bunch of there are 3.
well, okay, so we just found a mistake here, right? Because if Butch also belongs to Corey, what am I going to do? So in SQL, and when we're dealing with databases, we don't do this kind of thing, where we don't have, if you find that you've created a situation where you wish you had an array of information, you've designed it wrong. Okay? And that's okay, that's a totally normal mistake to make. But so if you belong to something, you're the one who has to carry that ID. Okay, so what do I mean by that? We're not going to change the users table because the user doesn't belong to the pets. The pets belong to the users. So instead we're going to add a user's ID. Notice I'm using the name of the table, underscore ID. Okay? And here is where we'll say, okay, well, Brewer belongs to Corey. Butch belongs to Corey. And we'll say Brutus belongs to Noah. Brutus.
I get to choose?
Sure.
Let's make it a true. You got 3 pets.
Oh, man. Okay, all right, I'll keep Brutus. Butch can go to, let's say, John. Okay? Right, so now we have this connection here. So this key, when we have a column on the table that refers to a different table's primary key, this is called a foreign key. Okay? It's from, like it's foreign. It's from another table. Okay? It's referencing another table. Yeah, Will.
So, going back to the same example that you said before, that it cannot be in this one. What if Brutus is owned by is owned by you and Jenny?
Awesome. We're gonna get to that in just a minute. I will repeat that question, but I just want us to, no, I don't want us to get sidetracked yet. What else? Any other questions on this? Cassie, what's this row called? Foreign key, perfect. Okay. Okay, great. So, Will brings up a great point. Will essentially said, hey, I know you said for this exercise we're just going to pretend it was one-to-many, but we already kind of determined that the relationship is many-to-many. How are we going to handle that? So now, if Brutus is also owned by Jenya, is that... Jenya and I went in on a cat, right? How are we going to store that piece of information? Any ideas? Kong?
Set a second foreign key.
Set a second foreign key.
Like secondary user ID.
Like up here or something.
Like on the path. Like the user ID is your primary ID.
I could add another user.
ID.
I like that. There's a concern to me, like how? What if I have like 5 owners? Then I don't know how many columns I'm going to need. But I like that. What else? Any other ideas? Karen? Awesome. So Karen suggests, why don't we make a third table? Right? This is going to be called a join table. Right? That'll be reinforced later when we learn more about SQL. So a join table is what's going to connect a many-to-many relationship. So let's just go ahead and write join table connects. Oops. Many relationships. Okay, so now instead of having this user ID column, so let's just go ahead and like scratch it out without actually like deleting it. Okay, so that table's gone. We could create a table, let's say, called ownerships. Something that is an aptly named for what it's representing in join. So I'll make an ownerships table. I don't know how to spell it anymore. I've totally spaced it out. What? Yeah.
There's no key. Oh, no, we got it.
Got it. It's in my head now. Thank you. Ownerships. Totally blanked out. It was weird. Okay. Well, thank you for all the. There's like a lot of spelling changes in there. People were like fast. Okay. Ownerships table. And so for this, it's still going to have an ID, just like all of our tables. But now this is going to have 2 columns. It's going to have a user's ID, and it's going to have a pet's ID. Okay, so now GREUP can belong to Corey. So I'll say ID is 1, GREUP is 1, pet is 1. Second entry, Butch we said belongs to John. So Butch's user ID is 3, pet's ID is 2, and then Brutus we had ID of 3. So the user ID we could say is 1, pet ID is 3, but also belongs to Jenya. So we also have a 2, because Jenya's ID is 2. I know it's getting low to the ground, I apologize. And the pet's ID is 3. Right, so this is a way for us to avoid having to create some kind of weird array in a SQL table. This may not make it look more clear yet, but it will make more sense as we actually start interacting with the tables. It'll become abundantly more clear why we're doing it like this. Questions on that? Kelvin?
How is it that they're talking to each other? Like, is it just the user ID from the previous table?
Is it just what?
How is it that they're like interacting with each other? Is it just the user ID from the previous table?
Yes, so the user ID, that's a great question. So he's saying, how are they interacting with each other? Basically, how is our ownership table getting this data, yeah? So the ID still represents every time we add something, or a new row, we get a new row in the table, right? The user ID refers to the ID from the users table, which is saying which user we're talking about. So for this entry, we're talking about Corey. This entry, we're talking about John, Corey, and Jenya. Our pets ID is referring to our pets ID column on our pets table. So this entry is 1, referring to Griot, it's Butch, and Brutus, and Brutus. So how is it actually getting that? Well, that's going to come when we're a little bit further along within the language. We're going to be able to add things to the database. And so when we create this joined connection, where it's a many-to-many relationship, we'll have to add 2 specific entries into this table. And that's going to be okay. That will be allowed. So far we've mostly just talked about theory about the database. Essentially how it's going to be used, what we're using it for. Most of the SQL is going to be self-guided through a lot of these exercises that we have, but I'm going to introduce you to the basics of that now. Okay? Unless we have any other questions on this. Okay, so if you want to follow along, I posted this link in Slack for SQL Bolt so that you can have the same database that I'm playing with right now. I really recommend you read all of this on your own at home tonight or tomorrow. Your homework will be to go through SQL Bolt 1 through 12. But the practice today will be SQL Zoo with a pair. So let's talk a little bit just about how these things work. So essentially we have this table. We don't have to worry about how it's been created yet. We're going to learn all about how to create tables later. So we have this table. It's got an ID. It's a table called movies. It's got a title, a director, a year, and a length in minutes. Okay? So, the way SQL queries work is there's all these cool things we can type in, but we're going to start with the most basics. So the most basic query you can make is you first say what you want. You say which columns you want. So let's say I say select, and I say I want the ID, and I want the title, and I want the year, let's say. That's all I want. Typically, these are in all caps. Sorry about that. It is case insensitive, but the standard is to be capitalized. You'll want to space these out on multiple lines as well. So we say select the ID, title, year. The next part we need is the from. So where we want this data from. So for this situation, we want it from movies. And there we go. This interface is automatically making this query for us, so we don't even have to edit it. And so you can see it's pared it down. It gives us back a new table. When you make a SQL query, you get back a new table with the specified rows and columns. Well, the return rows from the specified columns. We will have a way to make it so it returns JSON. That's coming later. That's with something called PG promise. But for now, we're just going to be returning a new table, which is essentially some kind of subset or something of the larger table. All right, so go ahead and select. I just want to see the title and the duration of the movie. Take a minute to figure that out. Okay. Let's do that for 3 minutes. No, I don't want to see that. Yeah, you might not.
Title and the duration to the title of the lens.
I want just the title and the length in minutes.
I know it's not so I'm really ready to I'll listen to it.
All right, clap your hands once if you can hear my voice. Did we get it? Nice. Okay. Overall, we got it. Who wants to tell me how to do it? Yeah, let's do it, Rafid.
Select title
Select title,
and length underscore comma.
comma,
Underscore
length underscore minutes.
and then we select
Nice. Great. This is pretty cool. It might not feel that cool yet, but it is. If I wanted to just grab everything, the shorter version for me to do this is to write star. Star means everything. Okay? Otherwise, you separate things with commas. Oh man, I can't do this much longer. Okay. My voice is getting tired. Okay. Next kind of cool thing. I mean, there's so many to teach, but you're going to learn most of it just working through the exercises. The other really big thing you'll use a lot is a where. And that goes after your from. So you say select, let's say star, from where, from movies, where, and now we can specify things. So we could say where year is, let's say 19, year equals 1999. Okay, so in 1999, Toy Story 2 came out. We could say where year is greater than 1999 to get all of the more recent movies. Okay, so equal, right? It's not triple equals here, it's just equal. The greater than, the less than, those all still work. Okay, those are comparison operators. If we wanted to order this, as you can see right now, it's coming in this, well, who knows what order this is coming in, right? It's a little weird. We can then add an order by. We can do this at the bottom. We could say order by And then we can specify the column we want everything ordered by. So let's say year. So if I order by year, now it is in ascending order, right? Starting off at 2001 and going up to 2013. That is the default, is ascending order. If I wanted it to be descending, I would add descending. Not too bad, right? It reads a lot like English. That's the great part. There is going to be some tricky little ordering things, especially when you get to having group by and aggregate functions. But I'm probably not going to go into those today. I think it's already been a lot. Any questions on this? Okay. Then we will post pairs. Start